Welcome back, students. We will continue our learnings on the chapter electricity. So, in the part 3 of this video, we are going to cover measuring devices, that is mainly the ammeter and voltmeter. So, quick catch up of whatever we saw in the last video. Kindly do not miss the last video. We mainly focused on what is the direction of flow of current inside and outside the circuit, that is inside a battery and outside a battery, which is opposite to the direction of flow of electrons. We saw the main difference between current and voltage, how electric charge is calculated, and we also saw the calculation for electric current. Just as a refresher, because the idea of electric current is very important, let me go through the electric current again. Electric current definition is nothing but it is the flow of electric charge through a conductor per second. Electrical charge is calculated by the formula Q by T. That formula is Q by T. Q is charge, time is second T, and Q we saw was the number of electrons into charge per electron. That's how there's a difference between capital Q and small q. So please note that small q is the charge for the uh, electrons per electron. That's 1.6 into 10 power minus 19, whereas capital Q is the electric charge. So we are going to measure this current using a device called as ammeter. A unit is amperes. So one most important repeated question is the definition of 1 ampere. So 1 ampere is the current formed by the flow of 1 coulomb of charge. This is also 1 in 1 second. This is also 1. So you get the formula. You know the formula is electric charge by time. Well, just we saw that. So 1 ampere is equal to 1 Q, that is 1 coulomb in 1 second. So this is a quite often repeated question. We will see more of this when we discuss the past board papers. So now when we saw that ammeter is used to measure the flow of current. So this is the ammeter what you see on your left, on your right, sorry, on your right, whatever you see, this is the ammeter, and this is used to measure the flow of current. It is connected in series to measure the actual flow of current through the component. So now I am going to bring in newer terms like what is series, what is parallel, what is resistance, all that. So for the moment, this ammeter definition might be little fall off the line, but when we cover subsequently what is series, what is parallel and resistance, I will again come back to this topic so that you'll better understand this well. Okay. So ammeter has a low resistance, so it doesn't affect the current when placed in series. So this I will explain in the next image where I have a circuit diagram. So the scale normally it's 1 ampere. When there is a small current flowing, it could be milliampere. Note this milliampere symbol because there are problems which they will give you like 20 milliamperes. You are supposed to multiply with 20 into 10 power minus 3 amperes. Or if it is very small, it is recorded in microamperes. Micro means 10 power 6. The problems could very easily give you as 500 microamperes, in which case you are supposed to convert this 500 microamperes by multiplying with 10 power minus 6 and make it as ampere. So now let me explain this. First, the second point, whatever I told you was it is connected in series. What is the meaning of series? See, here is a load. Load means anything which is your electrical appliance. It could be a light, fan, geyser, whatever. It is the load here. Okay. And this is connected in series means next to it, it is kept the end of the ammeter is connected to one end of the load. Okay. Note the direction of the current. See here there is positive symbol and the current direction is from positive to negative. This is something which you are supposed to note. The ammeter current is always kept next or series before the load. Before the load to measure the amount of current that is passing to the load. The load could be anything as I told you, fan, light, geyser, refrigerator, washing machine, whatever. So it is kept before the load. The third point what I told was it was having a very low resistance. So bear with me till I explain resistance. It might be little difficult to understand, but I'll try to make it simpler. See, without this ammeter, there could be 10 amperes of current. Let us assume that for the moment there is no ammeter. Okay. For the moment there is no ammeter. There is 10 ampere of current going to the load. Now I am going to place the ammeter before the load. Now I'm going to place ammeter before the load. Now ammeter is there. Now what will happen is, just because ammeter is there, the current to the load should not reduce. Like, the ammeter should not obstruct the flow of electrons. It should not resist the flow of electrons, so that this 10 ampere doesn't fall down to 5 amperes. Otherwise, if it falls down to 5 ampere, then your fan will not work. So just because you are putting ammeter here, your current to the load should not reduce. So 1 minute, let me clear this. So the ammeter device is having a very low resistance such that it doesn't reduce the flow of current to the load. So that is the meaning of this word. It has a very low resistance so that it doesn't affect the current when placed in series. The presence of ammeter should not affect the load. That is as simple as such. Okay. Now let us move to the next thing, that is voltage. We saw what is current. Now we are going to voltage. Voltage, we know, is the electrical potential difference between 2 points. So let me take this example of circuit. This arrow mark represents the direction of flow of current. Okay, current is flowing. As it flows through the bulb glows. And this battery is the source of power, which has two ends. One is positive and one is negative. The difference of potential between these two ends is called as the potential difference. This battery is what provides the push to put the electrons in the conductor. Okay, the battery has the voltage. So the electric potential is the difference between 2 points, which 2 points means this positive and this negative, which pushes the current through the circuit. So how is it defined? It is defined by the work done by the external force. See, in the circuit, battery is like a external force. This is the work done by the external force to move a unit of charge. We know charge is Q, capital Q, unit of charge between 2 points. What are the 2 points? You have one positive and one negative. So this is the 2 points what it is talking about. Okay, between 2 points. The work done by the external force to move a unit of charge between 2 points in an electrical circuit. Formula is work done W by charge Q. So measurement, it is measured through a device called as voltmeter, and SI unit is volts. Again, this 1 volt concept is a repeated question. What is 1 volt? 1 volt is the potential difference between 2 points in a current carrying conductor. The same example will hold good. Whatever we saw, the whole same example will hold good. 1 volt, the potential difference between this positive and negative is 1 volt. When 1 joule of work is done to move a charge of 1 coulomb from one point to another point. So this is 1 point. Whatever here seeing, this positive is 1 point, this negative is another point. So there is some amount of work done. So what is the work done? When I move from here to the first floor or the second floor, there is a displacement. I am moving from one place to another place. So there is a work done. Same way, when this electrical charge is moved from the positive terminal through the conductor to the bulb and again back to the negative terminal, there is some work done. So that's what is referred to as work done here. So the voltage is 1 volt is 1 watt, that is 1 joule. So not watt, I'm sorry, 1 joule divided by 1 coulomb. It's all in units, which is equal to 1 joule coulomb to the power of minus 1. Coulomb is the charge for is the unit for charge. Do not forget that. So this is again a repeated question. We will discuss more when we talk about board exam papers. And we saw that voltmeter is used to measure volts. So voltmeter is purpose is to measure potential difference across a component. It is applied in parallel. See, now here you have to note ammeter was connected in series, whereas voltage is connected in voltmeter is connected in parallel, so that you are measuring the voltage or the potential difference across two ends of a circuit. Okay, so it has a very high resistance. Again, this is contrary to ammeter, where ammeter was having low resistance, whereas voltmeter is having a high resistance. So if it is connected in series, it will affect the current that goes to the device or the load. That is the reason why voltmeter is connected in parallel. So I know it will be little confusing if you are not already aware of the concept of series and parallel. we will finish the concept of series and parallel and again revisit this to make it more stronger. So this is a complete circuit. So here you have a load somewhere. This you can consider as a load. Though I have given as a resistance, you can consider this as a load, which is your fan or light or whatever. I want to measure the voltage and current. So here you have the source of power positive. Whenever this positive, the arrow mark starts from there. Whenever you draw circuit diagram, this arrow mark is very important. It carries separate marks. Without this arrow mark, this diagram is of no use. So you need to put your arrow mark properly. So load. So you can see the ammeter is present before the load. Okay. That is before the current flows through the ammeter. I mean, before the current flows through the load, the ammeter is present to measure the current. So this is the series. Now, voltmeter. Voltmeter is intended to measure the potential difference between 2 points, between this point and this point. That is the reason why you connected parallel. You connected parallel to the load, and this is the complete circuit to measure the current as well as voltmeter in a circuit. Okay, so next video we will again refresh this concept of voltage and the main difference between ammeter, voltmeter, and proceed to understanding galvanometer. Thank you and bye till then.